All right, a model for the height of a projectile is given by h equals 16t squared plus vt plus h with a little zero that stands for h naught, where h is the height in feet, t is the time in seconds, and v is the initial upward velocity in feet per second. Like if you're throwing a ball upward, that's just how fast the ball's going as soon as it leaves your hand. H naught stands for the initial height. The little zero here, it's like an exponent but written underneath. That really stands for that. What it's indicating is the initial height, how high it was before any time had passed. That's kind of why they use a zero, like no time has passed. So equations of the form ax squared plus bx plus c can be solved by factoring and by using the zero product property. So here's a question. Suppose a cheetah pouncing on an antelope leaps with an initial upward velocity of 19 feet per second. How long is the cheetah in the air if it lands on the antelope's hind quarter 3 feet from the ground? Okay, so this is the equation for height. I know that the height when it hits the antelope is 3 feet. Now be careful, that's not the initial height. Okay, that's how high it is whenever however long it's taken to get onto the antelope. Okay, so the initial velocity is 19. The initial height in this case is actually 0 because when it starts, the cheetah is on the ground. Okay, it jumps from the ground onto the antelope. Okay, so this is my equation with everything plugged in that I know. Now I set it equal to 0 because it's a quadratic equation, and I can solve a quadratic equation by setting it equal to 0. Now, I multiply each side by -1 so that the leading coefficient is positive. Just makes life a little bit easier to factor. Then I multiply 16 times 3 and get 48, and I need factors of 48 that add to -19. Well, the only way that happens is if both the factors are negative. So I would have -1 and -48, but that gives you -49. -2 and -24, but that gives you -26. -3 and -16, that gives you -19. That's the one we're looking for. So you could write it as 16t squared minus 3t minus 16t minus 3. So group these two together, you could factor out, that should be plus 3. You can factor out a t, and you get t 16t minus 3. Here you factor out a -1, and you get 16t minus 3. So your factors are 16t minus 3 and t minus 1. Now using the zero product property, you set each of those equal to 0 and solve for t. This one you just add 1 to both sides, you get t equals 1. And here you get t equals 3/16. So why do we have two answers? Well, if you think about it, the cheetah jumps up in the air, goes up, and then comes back down onto the antelope. So at 3/16 of a second, that's when the cheetah is jumping up. He's not yet at the antelope. At 1 second is when he starts coming back down and lands on the antelope. Okay? So that's what time the cheetah hits the antelope is after 1 second. All right, here's one for you to try. Go ahead and pause the video and hit play when you're ready to check it out. Okay, a person throws a ball upward from a 506-foot tall building. The ball's height, h, in feet after t seconds is given by the equation h equals -16t squared plus 48t plus 506. The ball lands on a balcony that is 218 feet above the ground. How many seconds was it in the air? Okay, so they gave you the equation here, and they asked you basically, when is it equal to 218 feet? So you do 218 equals -16t squared plus 48t plus 506. Now you subtract 218 from both sides, and you would get -16t squared plus 48t plus 288 equals 0. Multiply by -1, both sides. So you get 0 equals 16t squared plus, oops, that's going to be minus 48t minus 288. And luckily, you can factor out a GCF of 16 from everything. So 16 times t squared minus 3t minus 18. And then since the new leading coefficient inside the parentheses is just 1, I just need factors of -18 that add to -3. And they're -6 and 3. Okay, so I set t minus 6 equals 0. And t plus 3 equals 0. Here I get t equals 6. Here I get t equals -3. Time can't be negative, so it must be that 6 seconds after the ball is thrown upwards, it lands on the balcony that is 218 feet high. Alrighty? Alright guys, that's it for this section. Please continue on to your assignment, and as always, reach out if you have any questions. Take care.